Assalamualaikum and good morning, everyone. We're gonna have a class lecture on computer neuroscience, okay? And today we're gonna talk about these three main important things. The first one is modeling a single neuron, modeling a network of neuron, and the last one is modeling learning in neuron. So these three things we're gonna learn for a few classes. And for the MATLAB classes, we're gonna find some other days, and we try to make the best environment infrastructure for the MATLAB. At the moment, we're gonna look at this syllabus. Now, let's look at the next slides. All right, brain. Okay, let's start. Brain is the most powerful creatures, that human can think something, thinking and make a decision, judgment based on many things. Okay, we live human as a human. We have lived in the world about say 30 years. Okay, and from 30 years we have learned a lot. We learn from what we observe. We learn from what we hear. We learn from what we touch, sense, and many things. So this thing gives us knowledge to be stored somewhere in our brain, and later on when we something, we be able to do a thinking. We be able to do not just thinking, solving the problem. We also be able to do some prediction. We have our own vision of life, probably something like that. So that's powerful of brain. And when regarding to the brain and computational neuroscience, basically we try to understand how the brain compute or process information. We not only try to understand how the brain compute and process information, we also try to model it. We try to model it to be algorithm, and then the algorithm that imitate how the brain process information and put it in the computer, and computer be able to do the thinking just like human brain. Okay, that's a computational neuroscience. And basically computational is not only just learn how the brain work, how the brain been departmental, how this portion of brain, what it do, what it did, how it work mechanism. At the end of the day, we also model it into an algorithm so that the algorithm be able to install in computer, and computer be able to do a thinking like brain. So in other words, computational neuroscience here, we try to understand how the brain compute and process information, and later we're gonna model it into algorithm so that when we install in the computer be able to do like the human did. In other words, computer be able to have a vision. Computer be able to make a decision. Computer be able to do prediction. All those things that human do. Okay, that's what we mean computational here. So we define the computational here a bit wide, a bit. Okay, so it's based on what area you are. In clinical, basically assess the sickness of the patient. Anatomy, basically you're gonna look at what are the function, how does it affect all those things, the component, the architecture, how they work, and so on, the others. So in computational, basically is to understand how brain compute and process information. Now look at the next slide. Okay. All right. So in this slide, basically, it is all function. Okay, all the function of the human. where the most important is brain, and these are all the data that input to the brain, and so that brain can make information. In my course, basically, I'm really focused on eyes. Okay, so eyes mean vision, what we see. Okay, what humans see, vision, computer vision. So that's come the word computer vision. When people see it, something, anything, people see it, process it, and get some information and make a decision, that's mean computer vision. Vision means see. Okay, not prediction vision like that. This is a vision, computer vision. Computer operate what are on pictures and video, something like that. So, okay, so uh, instead of what we seeing, also what we hear. Okay, hear mean you hear the sentence, then you translate it and understand it. That's what human do, brain do. We listen to human sentence, then the brain basically will process it and get information and make decision. Also from mouth, what we speak. So in this case, when we talk about ears and mouth speech, mean that it is about languages. Okay, NPL, natural language processing, NLP. And when we regarding to the eyes, we say is computer vision, mean vision. What you see, what you see basically is image and video. If you recorded it, then it transform to the brain, will process it and get some information. What you see. So this is the other data input to the brain. Okay, heart, stomach, pancreas, liver, and I thought these are data when you input, the brain process itself. We even acknowledge them. Okay, so this is what we're gonna learn today about the vision, mostly the vision. Okay, now let's look at the other slide, and before that I need to delete the yellow. Okay, so the next slide. So brain, okay, that's the circle one, is a brain that we are looking for. Now this is what is this all about? So just to show you how powerful is the brain human. Okay, what we see here, you can see a duck, and we as a human see all this is a duck. By glance we see it is a duck. Why we know this one? Simply because we have learned this for 40 years. Okay, we have learned this for 40 years, that this is a duck. By glance this is all a duck, and we human know this is a real duck, picture of real duck, picture of the real duck, and this is not a real duck, this is not real, this is a draw duck, and so on. So we try to program a computer to do the same what as I do. So the question is now, can computer do what I do just now? Not yet. Okay, not yet. I think they can do, but a little bit, The computer cannot do just what like I do, which is I know this is a duck, picture of duck, and this is drawn by a kid, and the kid is probably is standard 4, 5 primary school. Human can up to that stage. We learn memorize, we have some experience, we learn for 40 years, so we can, by looking having this picture, we can conclude and we can make a story. Can we do the same, try to program a computer to do the same? So the answer is not yet. Okay, we're not up to that because we haven't yet modeled the brain and transform it into algorithm, and so the algorithm can be installed in the computer and computer do the same. But in the future, it probably yes. Okay, we don't know how many years to go to achieve that level, and this is the same. Okay, by looking at this, we know as a human that this is what a chair. Even we just see some portion of it, but for computer it must be difficult. I don't think he can. I think for computer, if we to detect what it is take a bit hard work, just to let computer understand this is a chair, because it's just we just see some portion of it, because we learn a lot. Brain is a powerful, and we try to program a computer to do the same like what I did. If I can guess this is a chair by looking at this portion, I can know this is a chair. Then basically we want to try a computer to do the same. We try to develop a program to do the same like what I did. If you can do it, it's good, and it's not yet very good one now, but it's still there. Okay, and this as well. Okay, we as human, when we see at the glance, we know this is a dog, this is a chicken KFC, this is a dog, and this is a dog, and this is a dog. But for computer, if we try to computer to do the same, they're gonna have some difficulty, very hard job to do it, so these are coming how we can human do like this, because we human, the brain got the neuron. We'll see later the neuron function. Okay, and let's see. So the purpose is basically to try a computer program of the brain, and later on we can uh, install it on the handphone for the public people usage, for the world to use. So it's nice, to have a program software that be able to do the same like the brain do. So in this case, you're gonna see that the software basically looking at this number word and translate into welcome. So it's a nice application. Will be marvelous, application for the people to do it. And so the conclusion of this one is to understand, our course basically is to understand how the brain compute and process information. And later on, we're gonna chain it into algorithms so that we can install in the computer, so that computer can do the same like a brain to analyze the world, to make a decision, to make a prediction, and so on. Okay, now, so if we do understand the process, then we'll be able to create a software that is operate like brain neuron solving problem. Okay, that's clear to you. Okay, the information. Okay, let's next to the slide. So now goes to the word artificial intelligence. All right. So I think you are well known about the word artificial intelligence. Okay, and it's been since 1945. Artificial intelligence has been there, and just recently, within 5 years back, the AI is become booming now, and the AI become booming, and the industrial revolution 4 IR4 is emerged now simply because of the advance of the artificial intelligence. So the advance of artificial intelligence basically is coming from the neuroscience part. So we have a AI inspired by neuroscience, or in other words, we can say neuroscience inspired artificial intelligence. Okay, so today AI become a famous word. Okay, nowadays, and thanks to the neuroscience and neuron. So we're going to look at this. Okay, so in other words, the AI technology, the algorithm, computer programming in AI are all based on neuroscience kind of concept. Brain, basically, when we call it neuroscience, then means that it is a brain. It is a AI is booming today simply because the algorithm that they use is based on the brain concept, neuroscience. So that's why it become booming and become IR4.